Electrocardiogram, abbreviated as ECG, is a test that measures the electrical activity of the heartbeat. During each heartbeat, an electrical impulse or wave travels through the heart that causes by cardiac muscle depolarization followed by repolarization. In general, ECG signal comprises of five main components, namely P, Q, R, S, and T wave that reflect upon generated electrical impulse as atrial and ventricular are contract and rest. P wave represent atrial depolarization and PR segment represent delay of AV nodes. On the other hand, QRS complex indicate the ventricular depolarization, whereas T wave indicate the ventricular repolarizations. Changes in normal ECG signal can be caused by cardiac abnormalities, including cardiac rhythm disturbance, such as atrial fibrillation and ventricular tachycardia. Inadequate coronary artery blood flow, such as myocardial ischemia and myocardial infarctions, and electrolyte disturbance. Cardiac abnormalities is one of the symptoms that can be associated with the cardiac disease. Early detection of heart abnormality would lead to the early initiation of treatment that could save life. Thus, for this purpose, we propose a system that capable of detecting heart abnormality using artificial approach. Before I go further, I would like to emphasize that this system is founded by TVET Research Grant Scheme and has copyright with registration number of CRLY 000222346. Furthermore, based on this system, also we managed to publish 3 indexes paper. Without any further delay, I will detail our system. Our developed system name as establishment of rectangular domain features extraction method for heart abnormality detection using artificial neural network. As we can see from the screen, this system is presented in the form of graphic user interface GUI. It is essential to highlight that our developed system work on offline basis using MITH database. The system divides into 2 main panels, which are left side is the control panel labeled as input and the right side is the output panel labeled as signal. The control panel comprises of 3 components, namely input features and diagnose, which enable user to operate the system. On the other hand, the output panel will display the corresponding process. To operate this process, firstly, we click at the Load ECG Signal button. Upon clicking this button, we can see the ECG signal will display at the output panel. From this display, we are enabled to select data from 12 different patients. After choosing the selected patient, we can see the corresponding ECG signal are portrayed in the output panel. Then we will click on the segmentize button. This button will divide the ECG signal into 6 parts. After that, we will choose which segment that we will be analyzed. We need to key in the specific segment to be analyzed in the choose segment panel and click confirm button. By clicking the confirm button, the output panel will be highlighted the selected segment. Following this, we will click on the trim ECG button. The output panel will display the selected segment that we will be filtered. After filtering, we will click on the process ECG signal button. In this process, the output panel will display 8 rectangular overlapping in the filter ECG signal. As for features extraction panel, we click on the extract amplitude and extract duration buttons. By clicking this button, the display panel will display 7 mark points and simultaneously the table in features panel indicates 7 values for amplitude and duration respectively. Apart from that, the 7 mark point refer to the intersection between a rectangular pulse and the ECG signal. Last but not least, we should click on the classify ECG. By clicking this button, the system will determine whether or not this patient having abnormality heartbeats.